Okay, just going to go through the next sort of video series here where we're going to try and learn how to map an equation in the form y equals mx plus c. Two learning objectives here. So in the first one, we'll try and really understand what each variable stands for and y equals mx plus c. And then secondly, we'll try and map an equation in the form y equals mx plus c. So again, you can write these two learning objectives down in your notebook. Now for your GCSE studies again, and really your AS and A2 studies, you do need the ability to map a particular equation into the form y equals mx plus c. But before we really undertake these notes and I show you exactly what to do, it's useful just to sort of check what you currently know about this equation. So if you just want to write down these 4 questions to see what you understand what the y, the m, the x, and the c stands for, and write down in as much detail what you currently understand about them. So, in the meaning of these terms. So, first of all, y equals mx plus c is used for plotting a linear equation, and this will result in a straight line graph. Now, the y stands for the variable that's plotted on the y-axis, and I'm sure you're aware from your junior science and mathematics and whatnot that the y-axis is simply the vertical axis, which you can see outlined here. Now the x stands for the variable that's plotted on the x-axis. And again, the x-axis is quite simply the horizontal axis, which you can see here. Again, you might just want to pause the screen and copy down these notes before we continue. Now the m stands for the gradient of the graph, and this is quite simply how steep the graph is. And the gradient, which I'm sure you're probably aware of already, is equal to the rise of the graph divided by the run, which you can see labeled in this wee illustration here. The rise, the vertical rise, divided by the respective run. Now we can summarize that gradient. We use the symbol m for it. And so m is equal to the rise divided by the run. Just a wee quick recap from one of the previous videos for SIA. If you're working out the gradient of a graph for your exam, you need to use what SIA referred to as a large triangle. And that quite simply means that one side of that triangle at least must be 5 centimeters. So again, you might just want to pause, copy down the notes, as well as the diagram as well. Now, a larger value of m quite simply means that the gradient is larger or steeper, which you can see in this diagram here. So if you've got an increasing gradient, the line then turns counterclockwise as we view it and becomes much steeper. Conversely, if we've got a smaller value of m, that means that the gradient is getting smaller and the gradient is therefore becoming less steep, it's decreasing, which you can see in this illustration here. Again, you might want to pause the screen, copy down these notes. Now the c in the equation refers to the y-intercept, and this number represents the number on the y-axis that the straight line passes through when x is equal to 0. The most common example in both GCSE and A-level physics is when c is equal to 0. And in this case, you've got a straight line passing through the origin, which you can see in this wee diagram on the right-hand side. So again, you might just want to pause the screen and copy down these respective notes. Now let's say, for instance, that you had a graph and the value c is equal to 1. Well, then that graph will then be moved upwards from y is equal to 0 to y is equal to 1. If we're a graph whereby c is equal to 4, you quite simply move the graph up until the intercept is at y equals 4. So you might just want to add in those notes into your notebook as well. And that really ticks off the requirements of the first learning objective. Now in the second learning objective, we're going to look at trying to map a particular equation into the form y equals mx plus c. So a worked example will be provided and then a couple of other examples, but hopefully give you further experience of using this particular skill set. So again, you might just pause the screen and copy down these respective notes. Now here's worked example 1. So a student undertakes a practical to confirm Hooke's law. The student aims to plot the following graph. So they want to put the force on the y-axis and extension onto the x-axis. If you could copy out question 1 and try and map the equation for Hooke's law into the form y equals mx plus c, and then question 2, and plot the graph that you'd expect if the material does obey Hooke's law. So pause the screen, copy those questions out, and complete them fully. So you can see my solution there to question 1, my mapping. So you've got y equals mx plus c. Y is the force, the gradient m is the stiffness constant, x is the extension, and there is a value of c, it just happens to equal 0, which means that this particular graph should be a straight line passing through the origin. If needs be, you can pause the screen, copy down that work into your notebook. So you can see, of course, on the y-axis, we've got our force. On the vertical axis there, on the x-axis, we've got our extension E. And the gradient of that graph, of course, is the stiffness constant of the material, which you could use a large triangle to get in the exam. The C value, of course, is 0. So we do expect that straight line to pass through the origin. Now, sort of tying back into one of the previous videos, the units of m, the gradient, in this particular example are equal to the units of k, and they're always going to be the units of your y variable. It's going to be newtons divided by the units of your x variable, which happen to be centimeters. And so the units of the gradient, which is really the units of k in this particular instance, is equal to newtons divided by centimeters. And you might just want to copy down those notes into your notebook as well. Now, worked example 2, we will stick with the theme of Hooke's law. And I want you to do the same 2 questions, but the only difference now, and this is an important skill set for both GCSE but also AS and A2 physics. The graph has been inverted. You've now got the extension on the y-axis, you've got the force on the x-axis. Again, this is a skill set that students do struggle with from experience, but you are required to do. So pause the screen, copy out question 1, question 2, and complete it to the best of your ability, and then we'll check the answer. Now, to get the mapping in this instance, we're going to have to rearrange the equation for Hooke's law. And I'm looking to really isolate the E on its own because I want to plot that really on the y-axis. To do that, we're going to have to eliminate the k on the right-hand side. We can do that by dividing the right-hand side by k, but we also must divide the left-hand side by k. Those 2 k's will now cancel out, leaving us with f over k is equal to E. If needs be, you can pause the screen and copy down that working out as well. Following on from that then, so f over k is equal to E. E is equal to f divided by k. That's just really swinging that around, putting E on the left-hand side and f over k on the right-hand side. Now we need to appreciate that f divided by k is the exact same as 1 over k multiplied by f. In that case then, on the y-axis, we've got E for extension, and on the x-axis, we've got F for force. The gradient is now equal to 1 over k, a little bit different from our first worked example. So gradient is now equal to 1 over k. There is a value for c that happens to equal 0. And again, provided we haven't went beyond that limit of proportionality, we do expect to get that straight line. And because c is equal to 0, it should pass through the origin. So again, if needs be, you can copy out the notes into your notebook. Just in relation again to the mapping, you can see in the y-axis we've got our extension there. On the x-axis we've got our force coming down here. The gradient of this graph would now give us 1 over k, take a large triangle, and again, because c is equal to 0, we do expect that straight line to pass through the origin. The units of the gradient in this case equal the units of 1 over k, that different to the previous example. And they're always again equal to the gradient. Units are always the unit for your y variable, centimeters, divided by the units of your x variable, which in this case is newtons. And so the units for your gradient are going to be centimeters divided by newtons. And again, you can pause the screen and put those notes into your notebook as well. And the final example here, worked example 3, you can see Zoe thinks that the height h, which you can see in this diagram, fallen by a stone off a curved bridge depends on the square of the time t between releasing the stone and it hitting the water, according to this particular formula here. H for height is equal to k, which is a constant, times t squared. A graph of h on the vertical axis and t squared on the horizontal axis is to be plotted. Now, this is pretty much the sort of format you'd see from some of the past paper questions. Can you take a new page, pause the screen, copy out the notes, copy out questions 1, 2, and 3, and try and complete them fully, please? In relation to question 1, you can see my mapping there. So again, y is h. On the x-axis, we've got t squared. And again, you can see the gradient will give us this constant k. Now, there is a value of c. It just happens to equal 0, which means we do or should expect to get a straight line that passes through the origin. So you can see h in meters, that's t squared, and that is in seconds squared. It's just using an AutoCAD program here. There's no squared function. So just take that to be t squared. That is s, or seconds squared. Now, in relation to units, for the final part there, again, the units of the gradient in this case are going to be equal to the units of that constant k. Again, it's always the same format. It's the unit for your y variable, the meter, divided by the unit of your x variable, which is seconds squared in this case. And so the units of k from this equation are quite simply meters divided by seconds squared. And again, if needs be, you can pause the screen and write down those respective notes. That really ticks off the requirements of learning objective 2. So those 3 worked examples will hopefully be sufficient in terms of preparing you for your actual examination.